All right, so we're going to be talking about quote unquote instantaneous rate of change. And again, we're going to have a limited scope of instantaneous rate of change because this is not calculus. In calculus, you will learn how to actually calculate that value using that stuff. But that's not our job here. So we're going to use average rate of change to approximate the instantaneous rate of change. All right, when you move on to Coach Smith, he will teach you how to actually calculate it. All right, if you move on to Coach Smith, or if you take calculus in college, that's where you'll dive deeper. Okay, so on example number 5, who wants to start off our popcorn reading? Yeah, you were good. Suppose.
Oh, I see it. Suppose the object is flying upward from a height of 120 feet with an initial velocity of 48 feet per second.
Hop.
The height of the object, feet second after it is launched, is given by over the given interval. The units of measurement.
Okay. If this looks familiar to you, this value, this equation is because it came straight from your Algebra 2 notes. Negative 16t squared plus 48t plus 120 is one of the functions that we analyze in Algebra 2. So it wants us to find the average velocity in the first 2 seconds after the object is thrown. If I'm finding the average velocity in the first 2 seconds, which one did I change the notes?
Yeah.
I did. I gave you the intervals, right? Oh, no, I'm good. I did change the notes. Dang it. Cry me a river. If you don't have one, grab one. All right. So on your new notes, I added in intervals.
Oh, no, good.
Okay, so we're gonna modify my notes to match yours. So I have to go try to find it. So we're gonna find the average velocity in the first second after object is thrown, and we're gonna do so by finding the separate intervals. So right now we're gonna do 1, 1.1. We're gonna then find what is the other 1 and 1.01, right? And then we have 1.1, 1 and 1. As you get your calculator, you may want to reset it. My other class was doing statistics. So second plus 712. Second plus 712 to reset.
Yeah, who was doing all that crap?
The other class. Algebra 2.
Oh.
Second plus 712 is going to be your best friend. All right. So there we are. We're going to evaluate. So we're going to go. I need to pull up Sylvie. Here she is. Hey, girl. Second plus 712. And it's clear. Okay. So we're going to put in our y equals. So we have y equals. And our equation is negative 16. We're going to use our variable button, x squared plus 48x plus 120. All I did was put in the equation. No, because right now it's defined. It's if you were to change it to parametric settings, like change your calculator settings, then it would appear as a t instead of an x. But we're not in that mode, so no.
What's the point of this other level?
Because there are other modes of your calculator to use those other letters. Yeah. That's why it's called your variable button. Bless you, bless you. All right, so we have, everyone has their equation in? And we're going to approximate these values. Now, I'm going to do my very best to see if I remember how to do this. The calculator has updated, and there's like a little shortcuts we can utilize, and we're going to see if it works. But let me test it out first. Yeah, it does. I'm about to tell you. I had to make sure that the update works. Didn't you hear me say that?
I did, but I don't.
Thank you.
All right. So in theory, you should be able to table. So you see how if I go to second table, the value of y1 and x is what? 152, right? Now, with our calculator, we can actually do that in the calculator mode without having to do double the work.
How do you do that?
I'm about to.
No, on my on my table, I did.
Did you put in the function? Did you go to y equals and put in your equation?
Yeah, I
And you
did.
press x squared?
You got that?
Yes, you do. All right, so we're gonna find our values. So the first one that we're looking for is f of 1.01 minus f of 1 divided by 1.01 minus 1. Now, what I like about your calculator is you actually can create a fraction on your calculator. To create the fraction on your calculator, you're pressing alpha variable, which is the green button and the variable button, and you can create a fraction, correct? Alpha. Yes. One in, oh, I wrote it twice.
Go to the other side.
There we go. So f of 1.1 minus f of 1 over 1.1
Oh.
minus 1. All right, so you can press alpha variable, which is just the green button and the variable button. So you're going to press that first. I cannot because my calculator has limitations. When I press that, it does nothing. Okay. You're pressing alpha variable, which is the variable button is the button that has all the variables on it. X, T, theta, and N on the calculator page. You're pressing alpha variable and you should get a fraction. Yes?
Yeah.
Okay. This is the variable button where it says X, T, theta, N. It has all of your most commonly used variables.
That can be bars. I think that's also variable. You can do alpha or y.
Variations.
You got it.
Yes, I want you to have a fraction. Do we all have the fraction? Okay. I can't put a fraction. So I have to use parentheses. So I'm going to put in parentheses f of y.1. Well, it's not in terms of f, it's in terms of y. And I need y1, which is where I graph, right? This is here in y1. Agreed? Okay, so all I'm going to type is you're going to press alpha, trace, and it should allow you to select y1. Alpha trace should allow you to select y1, yes? And I want it to be defined at 1.1. Close parentheses. That's your numerator. You're putting. I can't make a fraction, Hudson. I said it 4 times. Minus, and I'm gonna repeat it again. Alpha trace 1, and this time the value I need is 1. I have to put parentheses because I can't make a fraction. You have a fraction, so you should be in your numerator. Yes?
That's still the numerator.
That is still the numerator. I just can't make a fraction. Your numerator is done. Now you're going to go to your denominator. I can't make a fraction, so I'm going to put the division symbol and use parentheses to do my denominator because I can't make a fraction. Okay? And I'm going to type in 1.1 minus 1. And I hit enter and it calculates the value. Then you type something in wrong. 100% did.
I put y1 in parentheses 1.1 out of parentheses minus y2.
Y2 is not what I said. You're going back to y1 because our equation is in y1.
Oh, that looks like y2.
No, it's definitely a 1.
No, I can't. It's like far. You need glasses.
So we get 14.4. And that's feet per second. Okay, now you're going to do it with the remaining ones. I will be around if you need help finding the other values, okay? Okay, I will be there to pull you back in.
Oh, yeah, that is the answer she got. There we go, I got 14. What is she?
All right, so again, your calculator is fancier than mine. So you actually can create a fraction, whereas I have to use parentheses to distinguish between my numerator and my denominator, right? All right, what did we get for our second interval? 15 point. Perfect. Our third interval. Look at y'all. And then our fourth interval. There we go. All right. Yes. Okay, so the bottom problem's asking you, this is how we approximate our instantaneous rate of change. Why do we have to do this? Because we are not in calculus. In calculus, you will actually learn how to calculate the exact value, but we approximate it by finding values that get closer to the value we're seeking. Does that make sense? So we were seeking the value of first second after the object is thrown. Remember, yours is updated, mine is not, so yours is prettier. Ignore my cross-hatch. All right, so the first second, so we're analyzing the behavior around 1. We're looking to the left of x equals 1, and we're looking to the right of x equals 1, all right? In conclusion, as we're approaching 1, what value do we seem to be approaching? 16. So therefore, ignore that. For 4 on your paper, t equals 1 is what? Our average rate is at t equals 1. The rate of change of the height is 16. Okay, but again, we have to approximate because we aren't in calculus, so we're not going to worry about the exact. But our approximation skill works, right? Okay, so again, in the calculator, making sure we're okay with it. Anytime you want to analyze a value from a function that you have put into y, you can go to the calculator page. You're going to press alpha trace and select where you put that equation at. Once it's in there, if I wanted to know the value of 100, I'm going to put y1 of 100. And it's going to tell me, here's your value of 100. Okay, you should cherish this gift because I wasn't given this gift. Okay, a little bit. Okay. All right. How do you feel? Good. All right. When you're approximating, you do have to use a calculator. So this would be a calculator-based problem. Got it? All right. Yes, Max.
What was the command to get the variable?
Alpha trace. Our command to get the variable is alpha trace. Got it? All right. So here we go. It says, we're going, number 6. Okay. So for each of the following functions, describe the average rate of change over the given interval as positive or negative. So right now, we're not focusing on the value. We want to know if it's positive or negative. Okay. That's what I want you guys to go through and do. So you're going to graph, look at the interval and tell me, is the interval a positive or a negative interval? Got it? So I'm about to model it on A. Give me easy killers.
Okay, I thought you were about to let us go on our own.
Okay, so I'm going to graph the parent function for quadratics first. I'm going to go to y equals, delete what I have in there. And I put x squared. That's what it says, right? And I'm going to go to graph. And there's my x squared. And it asked me to look at the interval from 2 to 3. So I'm going to trace and I'm going to look at my interval from 2 to 3. So what is happening? Is it a positive interval or a negative interval? Positive. So I'm going to write it down. From 2 to 3, I have a positive interval. I didn't want it to go to exactly to 2. I wanted to trace and work my way to 3. So you're going to press trace, and then you're going to work your way to 3 to see what direction you're heading in. Yeah, you're just analyzing your x's. That's all I'm asking you. Is it a positive? So graphically, I have this little sketchy sketch, and I'm going to say it's going up, right? Or it's positive. I just want you to tell me, what is your average rate of change doing? Okay? We will. Okay? So analyze it. I think we can do this fairly quickly. If you remember what a graph looks like, you don't have to use a calculator. No pressure. All right. All right. On the intervals, what did we get here for log? From 0.011. Positive. What did we get here on C? Negative. And what do we get here on D? Negative. Yes? All right. Easy enough to analyze? Yeah? All right. Next part. Where's mine? Crap. All right. We'll improvise. So it says here, the graph of f is shown on the right, the tangent line. So do you see this right here? This is called a tangent line. The tangent line is where you are going specifically through one point on that graph. Okay, not through multiple, but one singular point. Does that make sense? Okay. Yes, you should have learned that in geometry. So your tangent line is where you're going through one specific point on the graph. So we're looking at the tangent line as it goes through x equals -3, okay? At x equals -3, we have a tangent line. It's at 3 1/4. We're gonna say 3 1/4. So we're gonna write -3, 3.25, because it's right above it. 3.25. Okay, and it's going to ask you, it says use the tangent line to estimate the rate of change at x equals -2. Essentially, all you're doing is finding the slope of this line. Okay, when it says tangent, all we're doing is finding the slope of that line. Got it? So I'm looking for the slope of this line. In order to find the slope of the line, I need to have 2 points, correct? So we have our -3 and 3.25. If I follow this line, it looks like -2 is at 7. Can I find the slope of the line? Yes. So we're using -2, 7, and that's going to give us 7 minus 3.25 divided by -2, 25. -2 minus -3, and a negative times a negative makes a positive. If you have $7 and you spend $3.25, what are you left with? $3.75. If you owe me $2 and you have 3, how much you're gonna have left after you pay me? $1. So your tangent line, the rate of change of your tangent line is 3.75. That's what it means when it asks you for a tangent line. Okay. From there, it's gonna ask you, like, can you write an equation of a line to represent that? Could you? Yes, because now you have slope, y2 minus y1. It says describe the behavior of the graph of f and the relationship of the rate of change at x equals 2. So now we're going to look at x equals 2. At x equals 2, we come here, we come down, and what do you notice? What kind of line is that going to create? A horizontal line. And what is the slope of a horizontal line? It's 0. Okay, undefined is vertical, right? Hoi vux. Horizontal is 0, and it's y equals a value, right? Does that make sense? So it says, describe the behavior of the graph. So the graph here is that it changes itself. So we went from a decreasing graph to a increasing. So this is the point where we change from decreasing to increasing. And from this, anytime a graph is doing that, we've learned that the tangent line slope is going to be what? 0, right? So the tangent line is 0, so therefore at x equals 2, your change, your rate of change, your ROC is 0. Don't know why I wrote the word 0.
7B is just drawing that line.
7B is just drawing that line. So anytime I draw a horizontal line, that means that the rate of change at that point is going to be what? 0. That's our big takeaway from that. Got it? Yes? Okay. The rest is just practicing drawing lines, finding slope, reading the tangent line, describing increasing and decreasing intervals. We can probably breeze through that on Friday, but you should have the basics to work on the assignment. Got it?
Right? Oh,
All right.
That way.
Yes, I'm not closing it.